Okay, so I know everybody wants to go to the cocktail, so I will do it short. So I'm going to talk about the empowering of Metaverse-enabled devices using the platform solution for contextual awareness, edge AI, and wireless connectivity. So a few words about our company, CEVA. It's not everybody knows this company. So basically, we are a traded public company in NASDAQ. We are licensing hardware and software IP since 1991. And there are more than 1.6 billion devices today in the market using CEVA technology. Of course, we are a worldwide operation, and we have R&D centers in Israel, US, and Europe. So the main technology that we are licensing IP for, it could be divided into two segments. One segment is the wireless connectivity IP, which is everything that is related to wireless, like cellular, Wi-Fi, Bluetooth, UWB, and other standards. And the second one is everything that is related to smart sensing, to everything that relates to sensors. So we are talking about things like computer vision, sound, voice, audio, motion sensor, edge AI, and others. And on top of that, we are giving our customers, we have a subsidiary company which is called Intrinsics that we can give to our customer what we call integrated IP solution. Is basically we are shortening the time to market and can generate full chip to our customer. So if you are talking about the extra devices, it's basically the point of entry to the metaverse. The metaverse is a big term, everybody 3D internet or internet 3.0, when everybody will be inside the internet. And in order to get to the metaverse, you have to have, of course, an extra devices. Now, extra device is required a very complex and multiple technologies. And what I'm going to talk about, our solution that focusing on three main challenges that related to the building these devices. So the first one is, of course, the contextual awareness. We are talking about any extra device will have multiple sensors. So we have to do that. The second challenge will be the perception. We're talking about hearing and seeing around whatever is around us. And the third one is the wireless connectivity. Of course, everything today is connected wireless. Nobody is connected anymore wired. So there are two kinds of wireless connectivity. One is the tethered, and the second is untethered devices. So when we are talking about contextual awareness, what does it really require? So it's required, as we said, multi-domain sensing, which means, for example, sensors like IMU. These are sensors for motion sensing or head and hand tracking. There are also sensors like microphone, basically to do a voice command or sound analytics or a chat between people. Then, of course, there are the environmental, which we are talking about temperature and lights and others. And there are the first one is the biometrics, which we can divide it into two application. One is our well-being, checking our health parameters like heart rate and others. And the second is basically identification and security. We are talking about fingerprint, face identification, iris identification, and others. So of course, all the data that is coming from the sensors need to be filtered, processed, and then fused for any scene comprehension. The result will be a user full immersion, like 3D image, 3D sound, and haptics that you saw previously. So the second challenge that we are talking about is the perception. And we are talking here mostly on the visual sensing perception. Of course, any XR device, AR or VR, will have multiple cameras that will look at us. And we need to do a scene analysis. For example, if we are talking about VR, we want to identify the object in the room and so on. And if you're talking about AR, for example, you want to identify things like buildings, people, board sign or other object. So for that, there are two main algorithms that is usually used for this perception. The one is a SLAM. It's an algorithm that determines the position and orientation of the sensor, which is us, the user, with respect to the surrounding. And the second algorithm is AI. Of course, we have to talk about AI. Everybody is talking AI, so we need to mention AI. But no, seriously, AI is important, and everything that is related to object recognition, gesture recognition, hand, fingers, or eye tracking, all part of this perception. Now, the last challenge that we are going to talk and we have solution for is basically the wireless connectivity. So, of course, all the devices has to be connected to the internet or to the metaverse. And there are today two kinds of connections. The one is tethered. Tethered, it means that the connection is via Bluetooth or Wi-Fi. And it is connected to your home Wi-Fi or home network or to your mobile device. This is the tethered. But in the future, we will see more and more untethered connection. We are talking about 5G, things like RedCap and EMBB. It's a standard in 5G. That will give you a more standalone experience, and you will not be needed near your home or your mobile device. So in terms of contextual awareness, one of the big things, fundamental use case, is motion sensing in XR and spatial audio is, of course, the head tracking. Now, the head tracking is very important. That will be low latency, very accuracy, and very smooth. If it is not, it will create a very poor user experience, and the performance will be bad. So one thing that we know that the human brain become disoriented if it sees something different than what the other sensors of the human reporting. And then it could came to something like nauseous or motion sickness or disoriented and so on. So if you're looking about sensors, so all sensor has irregularities and anomalies. For example, if you're talking about accelerator or magnitude or gyro or any other sensors, they have some kind of anomalies. We are talking about gain, drift, offset. All these things are happening because of the environment. All these sensors have aging or temperature changes or voltage or manufacturing issues. Of course, this will be affected by the operation. The operation will be bad. And in this case, we are talking, for example, on angular error of the display, which definitely will destroy the user interface and will create a motion sickness, which is definitely not nice. So what are our solution for that? When we are talking about that, we are talking about some holistic sensing and contextual awareness. Basically, we are taking all the information that is coming from the sensors, and we are running it on our software that is called Smart Sensing software. This software can run on our DSPs and our processor, and I'll talk about a little bit our processor later, but also can run on any other processor. This software will do the contextual sensor fusion, of course, and one of the unique things that we can do that other people cannot do is the static and dynamic calibration. We can do calibration on the fly, which is very, very important for sensor. And of course, we run some specific application which will give the output to the right device, like the AR/VR or the controller or even the hearable. The second issue that we talked about was the perception, and this is more related to, as we said, whatever we see or whatever we hear. And for that, we are using our hardware and our software as a solution. Basically, the hardware will be a processor which is called the SensPro2. It's a very strong processor that helps to run AI and any computer vision or sound algorithm, including the motion sensing. And this processor is taking all the information from the sensor, all the sensors that we talked about, like the microphone, cameras, time of flight, IMU, and others, and do the processing on it and give you the right output. This is a family. It has, if you are familiar with the terms of performance that is measuring by processor, we're talking about 0.2 teraops up to 3.2 teraops. It is a modular architecture. It has a dedicated instruction set architecture, meaning that it has some specific command in order to do processing sound, imaging, the SLAM, of course, that is heavy loading, and any neural network inferencing. Now, one thing that I didn't talk about and is crucial definitely for any XR devices is, of course, the power efficiency. So power efficiency is a key in any XR devices, not only if we are talking about devices that is battery operated, also any other devices. Basically, you put your XR or AR, VR on your head, you don't want it to cook your brain, it will not be nice. Maybe it's a good egg, but not nice. So the power efficiency is crucial, and this is one of the strengths of all the solutions that we are doing. This is the most important. Of course, on the processor, we have full software that I will talk about in the next slides. So if we are talking about the SLAM is a process to determine the position or the orientation of the sensor in respect to the surrounding. And this is essential technology for XR to obtain your visual positioning and to track the object scenes. Now, it is very important and very improving the user experience. It is still a problem because the SLAM is very heavy loaded algorithm and it's very energy consuming. So we definitely provide the SLAM, what we call SLAM SDK. It's basically a full software solution that's related to SLAM that is offloading all the heavy duty algorithm and blocks to the DSP. It's not using only the DSP in the system, but it's offloading the main algorithm to the DSP in order to get the best high frame per second and the best power efficiency. So what are the models of the SLAMs? There are three main models when we are talking about SLAM. Tracking, which is basically the device motion estimation. This is not a heavy load algorithm. Then we have the mapping, which is estimate the 3D position of the feature point. This is more heavy load. We are talking about a matrix calculation of 200 by 200. And then, of course, the last one is the loop closure, which is the most heavy. It's really heavy algorithm and required a lot of processing. The next thing that we talked about is the AI that's related to everything that's relevant for object detection or to any recognition and so on. So for that, we have a variety of tools that help you to run your AI. So the first tool that we are doing is it's offload tool. It's not related to the processor or to the hardware. It's running on the servers. And basically, it's taking a trained network and run it in the tool and doing actually optimization, what we call retraining of the networks and getting a better optimized network. This is an offload tool. It's not related at all to the processor. Then the second thing that we have is something that we call system architecture planner tool. And this is, if you know about AI in general, one of the most problem, and I think the guy before me discussed about the memory bandwidth and so on. AI is huge memory consumption. This is the key challenge in any AI application, in any AI processor, and so on. So these tools let you, to the people that build the system, let them define and plan their architecture in terms of optimization regarding the memories. It's basically let you choose how much memories you need, let you choose, give you the information about the memory bandwidth and DDR latency and so on. The third tool is the CDNN, the CEVA Deep Neural Net Compiler. I will talk about it in the next slide. And after that, the last point, we'll take the last network and we'll run it on our processor to get the best results. So we are talking about a CDNN compiler. Basically, it's a tool that take any network. You don't need to know anything about our processor or our AI accelerators. And you run your network through this tool, and it will generate the optimized network to our processor. It's doing it, some of it offline, some of it real time. And it's doing all the features like scale per channel, multi-stream execution, asymmetric quantization, and others. All this will generate a very optimized network that is running on our processor. So on the other hand, we talked about the perception and the contextual awareness. On the other hand, we are talking also on the display and what the user is getting, the interface for the user. For that, the Immersion, we have a platform that is called the Bluebud platform. This platform is a platform to run a connectivity, which we talked about, the Bluetooth, and the audio IP platform for wearable. Basically, this is a platform that has inside our DSP, and on top of that, we are running the full software to run the full connectivity and audio together. We are using this platform to run our 3D audio IP solution. By the way, we have a nice demo in our booth if you want to step by that show this 3D audio. So the 3D audio solution is based with us on the Bluebud, the hardware. On top of that, we are running the CEVA motion engine, which is the software of, if you remember, that do the precise head tracking, and the software for creating the virtual placement and the sound anywhere in the 3D space. The nice about this solution that it is content agnostic. There are solutions today, for example, like Apple and so on, but you have to run their content. Here we can run anything, any content that you want, and you still get the effect of the 3D audio. And the last challenge that we talked about is basically everything that's related to connectivity. Here we are talking about, of course, we have the Bluetooth, Wi-Fi, but this is commodity today. So this is what is new, is everything that is related to 5G. Everybody is talking about, of course, XR or AR, VR. Again, will require the very huge bandwidth. We heard before me in the presentation before me. So the traffic and the data is huge. So for that, we have a solution for building a full baseband for 5G. There are two standards that our solution support. Of course, one is the RedCap, is the reduced capacity, meaning lower bandwidth, and the second is the full 5G that support the full standard of 5G. So our 5G solution is basically, we are the only one that has in the market a 5G IP solution. This is basically a hardware acceleration for major baseband processing. And it is optimized in terms of hardware and software partitioning to meet a very tight power consumption. You remember, power is the key. So to summarize about the solution, and as we said, the XR required a very complex technologies. We support most of them. In terms, we talked about, we have the vision AI, the sensor fusion, of course, the communication, connectivity, audio voice, including software on top of that. And we have other technologies that are also relevant, like security or secure ranging, that I didn't talk in this presentation. Thank you. If anybody has any question.
Can you discuss some of the prime use cases or give some stories of how your product is being used?
Basically, we are in the beginning of the chain. So if you see, for example, a device like this one, so the chip inside has our IP. So as I said in the beginning of the presentation, we are using around 1.6 billion devices. So there are many XR devices that is using our technology today. Mostly some of them in the computer vision, some of them in the connectivity that are using basically the Bluetooth. Our licensee use the Bluetooth and basically put it in their devices, and after that it's going to the market.
So what you're saying is that we can take parts of we can license your technology in a number of different ways, different components that we need. Is that correct?
Yes.
Okay.
Exactly. Basically, we mean that the chip manufacturers. So if you are not producing your own chip, you cannot license the technology. It doesn't make sense. It will go to the people that manufacture the chip, and they will generate it and will sell after that the chips for you or your company on whatever you need. Okay, so I think we can go to cocktails. Thank you. If we have a booth here, and you can come and see the demos, so it's very interesting.